While it's useful to find the key points for a parabola, the vertex here really is the most important one. And then in some instances, the x-intercepts and the y-intercepts won't be close by, and it's possibly going to be easier to create the graph by finding values that are close to the vertex. So I'll show you how to use a table of values to graph a quadratic function, a parabola. This works whether your function is written in vertex form, as it is here, or in standard form. So the first step is to find the vertex. Because we're looking at a function in vertex form, our vertex is hk, or negative 3, 5. So I'll write that in the middle of my graph. For an x value of negative 3, we know that the corresponding y value is 5. What I'm interested in finding now is what happens to values that are close to the x value of negative 3. In other words, what happens when x is equal to negative 4? That's 1 to the left of negative 3, or negative 2, 1 to the right. Of course, because of symmetry, the value for y, the corresponding y value for an x value 1 to the left of the vertex and 1 to the right of the vertex will be identical. And then just to get a good idea of the shape of the parabola, we'll look at 2 steps to the left of negative 3 and 2 steps to the right of negative 3. Let's start by solving for the value of the function when x is equal to negative 2, or for f at negative 2. This is equal to negative times negative 2 plus 3 all squared plus 5, or negative 1 squared, which is just 1, plus 5, or positive 4. So when x has a value of negative 2, the value of the function, the value for y, the corresponding y coordinate, is equal to positive 4. Due to symmetry, when x is equal to negative 4, the y value will also be positive 4. What about f at negative 1? When x has a value of negative 1, here's how we find the corresponding y value. Dropping in negative 1 for every instance of x gives us negative 1 plus 3 is positive 2 squared is 4. So we have negative 4 plus 5, or 1. So the value when x is equal to negative 1, the value of y is positive 1. That means that when x is equal to negative 5, the value will be positive 1 as well, due to symmetry. Try it. Substitute in the value for x is equal to negative 4 and x is equal to negative 5, and find the value of the function. I've just copied the values into this table. So we have a vertex of negative 3, 5. I'll start by plotting that. And then maybe it's a little clearer to see why I chose the values for x that I did. So the x component of the vertex is negative 3. So I'm interested in what happens close to the vertex. So I looked at x values that were 1 to the left of negative 3, in other words, negative 4, and 1 to the right of negative 3, in other words, negative 2. The corresponding y values were both 4. So we found the point negative 4, 4, and negative 2, 4. Now just to get a clearer picture of the parabola before I sketch it in, I checked for 2 more points. I looked at 2 points to the left on the x-axis of the vertex, or negative 5, and 2 points to the right of the vertex, or negative 1. The corresponding y values for x values of negative 5 and negative 1 were positive 1. We had found the points here, negative 5, 1, and negative 1, positive 1. With 5 points, that's more than enough to sketch the parabola. You could absolutely have used the vertex in this situation as well as the x and the y intercepts to sketch it. This is just another option.